Let's have a look at running Rapids in AWS using NVIDIA NGC, which is available through the Amazon Marketplace. No additional charges there above the normal EC2 virtual machine instance costs. Now, what Rapids is, think of basically Pandas and scikit-learn all wrapped up and running on a NVIDIA CUDA compatible GPU. As the name Rapids implies, this lets you run Pandas type preprocessing code completely in the GPU off to a model such as XGBoost, like we'll look at in this video, all very, no pun intended, rapidly. However, it can be kind of complicated to set up Rapids. You've got to have the right CUDA drivers. You've got to install it into Python and have the appropriate versions. And this changes as these new versions come out. That's where NVIDIA NGC comes along. NVIDIA NGC is essentially, in this case anyway, a collection of Docker images that have things like Rapids, TensorFlow, PyTorch, and all the transfer learning libraries that you may want to pull into them, all available as Docker images. You can run these on your local computer like I have here. I have videos on that. Or you can run them completely in the cloud, and they make it very easy to do this. I'm going to show you in this video how to get Rapids up and running on the cloud. We're going to use real data from my hard drive, upload it into Amazon, so that we can see this really end to end. Because a lot of the examples out there, they use generated data or they use some magic scikit-learn function that automatically pulls in a data set. We're going to use real data that we generated. You're going to see how to get that data into the cloud and processed using NVIDIA NGC. I'm going to show you in Rapids how to take a real data set. We're going to actually download the data set. I'm going to get it into Amazon S3, and then I'm going to move it into Amazon ESB so that I can actually mount it and get access to it. This is just the approach that I use for Amazon File Systems. There may be other ways to do this. Let me know in the comments. How do you get files into Amazon, and how do you like to process these in EC2 instances and other locations? A lot of Rapids demos use either generated data or data that they get magically through scikit-learn. Let's use real data that you actually upload. I'm going to use the Otto Group Classification Challenge. This is an older Kaggle competition that I competed in back in the day. We'll download the data. It comes in as a zip file. This is not particularly large data, but this shows you how to go through the steps, whether you have gigabytes and gigabytes of data. So I'm creating a S3 bucket. It's called Heaton load data. This is public. You could just do S3 : Heaton load data to get to it. I'm not opening it publicly though. You'll just get an access denied if you try to, but these have to be unique. I've created a folder in here called Kaggle, and I am going to upload the files here. Perhaps the easiest way to go about doing this is just to go into the Otto Group Challenge zip that you just downloaded, and then I can literally just drag them right onto the S3 bucket and upload them. There's nothing special about this S3 bucket. I need to remember that destination because I'm going to be using that in a moment. Upload successful. I now need to do some work in IAM. So let me show you how I set this up. Basically, users are how human beings access IAM, and also how, if you wrote a Boto 3 script, you would need a user for that. Roles are how different Amazon services access each other. And then policies are fundamentally what you're giving them access to. So let me get into roles. What you would want to do is create a role, AWS service. You would do EC2, because we're going to use this as a role that our EC2 instance runs in. You would go to permissions. You would create a policy. Policy is the JSON that actually specifies what you have access to. You could use these high-level ones, and just for testing, that might be fine. But I like to do this a little more fine-tuned. This is what I'm allowing this role to be able to do. You can see here I have some ECR capabilities. This is to allow me to communicate with NGC to pull the Docker images from NVIDIA. I also have some S3 capabilities so that I can download those S3 images. And this is the resource that I'm restricting it to. So this role only is able to access that little loading data, my data lake basically. I have this complete text file of this one because this is a pretty good sample one if you wanted to do exactly what I'm doing here. It's in the GitHub repository that is linked to the description of this video. Okay, I'm going to create a new EC2 instance. I'm going to go to Amazon Marketplace. We're going to use the NVIDIA Deep Learning AMI. This is what you launch NGC from. It's a very useful AMI image. It has all the NVIDIA drivers and NVIDIA Docker completely set up, ready to go. I'm going to use the recommended machine, which is about $3 an hour. However, since I'm cheap, I am going to use a spot instance. I use spot instances a lot, and I rarely get kicked off. I usually set my code up so that it doesn't matter if I get kicked off. This is also very important, the IAM Role. That's where I'm going to use that Heaton EC2 Wikipedia one that I set up. I'm reusing that. I use that to process a Wikipedia example. But I have the complete IAM Role available in the description. Let's go to Review and Launch, and Launch. This is the key pair that I always use, at least for demo. Let's take a look at that instance. No running instances yet. Refresh. Launch Putty, put the IP address in there. Go to SSH. I'm going to add my PPK file. Again, this is all covered in my previous AWS Crash Course video. Set up my tunnel, 8888, add, and that's it. This should connect. I will accept, and we're going to log in as Ubuntu. Okay, I'm going to run Docker, just because that takes a little bit the first time it pops up. Let that run while I create the new hard drive for this one. Go to EC2. So this is the EC2 control panel. Elastic Block Store, EBS. Go to Volumes. I'm going to go ahead and create a volume. This is a new one. I'm going to make it 26. 25 is a nice even number, but this way I won't confuse it with one of my other ones, and I can make sure that it's absolutely mounted and I don't accidentally format one of my others, because we're going to have to literally format this. You don't have to match the 1B part, but it'll be faster. So long as it's in the same region, you're not going to pay anything for transfer fees, which is a good thing. I am actually not going to encrypt this. I don't have anything particularly sensitive in this. So I will go ahead and create the volume. It gives me the volume ID, and I'm going to go right to it, and I am going to choose to attach it. You have to attach it to what you're going to use. On my real Amazon account, I have a bunch of these, and I tend to just reuse them. I keep files here that I need. Like I have one that's all preloaded with the latest version of Wikipedia I downloaded. I use that for various things. I only have one instance running, so that's nice and easy. We're going to connect to it. The device is dev SDF. It doesn't actually connect there. It connects somewhere else, like it mentions here. We'll actually go and find it. I don't like relying on that anyway. So let's click attach. It is now attached, even though I literally had this running. Okay, so Docker has finished. That is good. Let's go ahead and mount that drive that I've created. I'm going to use some commands that are right on the GitHub repository that I have linked. So these are commands that I'm going to copy and paste because I'm lazy and I don't have them memorized. This is going to list the block devices that I have. So I'm going to move that over to there so we can kind of see this whole thing. So I run this as sudo. And let's look at what's going on here. These are the loops. Don't worry about that. That's for Amazon. This is my boot volume. I don't want to accidentally destroy that. This 26 gig, remember how I made it 26? That way I know it's the real one, because I'm about to nuke this thing. I can't mount it yet because it's unformatted. I can copy this one. Now, if it's something other than XVDF, and it won't be unless you have multiple of these mounted, that just shows you the information on it. Notice its name is data. That's what I created it as. It doesn't really have any file system on it. That's what this command is going to do. This formats it using the XFS file system, and we're going to format it. Only do this once, unless you like erasing all the data on that one. It formats extremely quickly. So if you had something really important on there, it would all be gone now. And I'm going to mount it to my EC2 instance. Oh, I have to create the mount point first. So mkdir mnt already exists, data, and I bet this has to be done as root. Yep. So sudo. Now I can run that command, and now it's mounted. So I'll move into there. There's nothing in here. It's a completely blank volume. But what I'm going to do is run this command. So that runs the Amazon from the command line, S3, copy from S3, Heaton load, to my mounted Kaggle location, recursive, meaning copying everything in there. Exclude everything, but include CSV. That's just the weird way that Amazon does this. This is basically just saying copy CSV. So let's run that. Oh, I forgot to run this command. That basically gives my normal Ubuntu user access to that newly created mount point. So now I can do my download again. And it downloads those files. This is blazing fast. You can pull hundreds of gigabytes, and it doesn't take that much time because you're moving files on the Amazon backbone. So now I can see this Kaggle, and now I'm going to run the NGC Rapids Docker image. Now where I got that from is if you just go to NVIDIA NGC AWS, this is it. You pick the one that you want. We're going to do a couple of these in the next few videos, but I'm going to do Rapids. You pick this one. Pricing information, I love $0. That means NVIDIA is not getting any money. Amazon is still getting the EC2, but there is no markup. This is as cheap as it gets. If you do SageMaker, they put some markup on top of it. So this is running on a spot EC2 instance. I am flying standby on the airplane, basically. But this is a very inexpensive way to get access to these. So I'll continue to subscribe to Rapids. Continue. We will continue to the configuration. I am going to go ahead and use runtime because it's got all the libraries already loaded. And I will continue to launch. You want to view the container details. It almost gets lost here, but that is basically giving you the information here. We actually do have to log into NGC first. And by the way, this is why we gave that role access to the S3 bucket. That's how I was able to download from my S3 bucket and also able to access NGC. So we'll run that. That will log us in. Login successful. I already copy and pasted the runtime. You want to use the latest CUDA, but that's what I had over here in my repository. We're going to run it, interactive terminal with all the GPUs. We're going to expose that port, which is going to get tunneled. This mount that I'm doing is very important. I am mounting MNT data, so that Kaggle directory that I created on my host, mapping it to a Rapids Notebook host. If you read the documentation for the Rapids Notebook, this is where they want you to mount external data. So we will literally be able to see that hard drive shared inside of my Docker container. I'll show you a diagram of really what's going on with all these containers and EC2 instances, and then we run that. So let's go ahead, copy this, put that into here. It pulls the Docker image. Well, that's going. Let me show you a high-level view of really what this all looks like. This is my little diagram. I'm not the best at Adobe Illustrator, but notice that big instance that I have, the EC2 instance, NVIDIA AMI. That is when I launched that. Then I pulled the NVIDIA NGC Docker container into there and mounted my Amazon ESB connection, which I pulled the files from S3. This finishes downloading. And now I'm in here. Now notice how it says make a local folders visible by binding, mounting to Rapids Notebook's host. That's where I got that location that I put in the volume mount. So let's pop into the browser and see what this looks like. And there we are. Believe me, that NVIDIA Docker image makes this so easy. Everything is accessing the GPU and ready to go. We're going to look at XGBoost And they've got examples here. The examples don't really show how to pull data in and out of this system. That's what I'm trying to do with this one. Notice host we have here, Kaggle. Oops, I ended up creating 2 Kaggle directories, but you get the idea. So this is the files. I'm going to go ahead and create my notebook right there, just so that my notebook gets preserved. And here's my notebook. You can see it's untitled. I'll rename it. Let me just copy the code in here fairly quickly. You don't need to watch me type code. It's right here on the linked notebook too, so you have access to it. Here I'm inputting the OS that I need. cuDF, that is Rapids. So that is essentially data frames, just like in Pandas, for CUDA. And then cuML. This is going to let me do some label encoding, which I'll show you what that is in a second. You've probably seen that before. And then this is the root that I'm actually pulling it from. I specify this file location inside the Docker image. So Rapids Notebooks host, I wouldn't specify it to that /mnt data, blah, blah, blah. That's out in the host environment outside of the Docker image. So I have that. And this is how I'm going to load the file. I'm loading it just right from train CSV that is located on this mounted volume. I could also pull it from an anonymous S3 bucket, or I could put that same key and secret, remember that I showed you in Excel, just like you are doing through WinSCP. So these are all 3 different ways of doing that. And then I'm going to get the X, the Y, and target, and I'm going to use label encoder to transform it. Let's have a quick look at train. We don't want to use the ID, so we'll remove that. And we want to use target here. So this is a multi-class classification using all of these input values. Can you classify if it's target 1, target 2, all the way up through 9? That's a string, that's an ordinal. We need to encode that in some way. XGBoost doesn't tend to like dummy variables. We need to change that into a numeric value of 0 for class 1, 1 for class 2, etc., etc. That's called either an ordinal encode or a label encode like we have here. You really only want to use that for targets. Don't encode input values that way. Here I'm creating the X's. So we're taking all the rows and we're going from 1, skipping 0, which is the ID, up to 9, actually up to 1 back, because the 9 was because I had dummy variables in there earlier. I need to update that. So we'll take a look at X. You'll see X is feature 1 all the way up to feature 93, and we don't have the target in. So that's good. Y is going to be the label encoded target. So you can see I have 000 up through 888, which is good. Important concept here. sklearn has a label encoder, but I use the one out of cuML. You've got to do that. That keeps everything on the GPU. That's the whole sort of point of what we're doing. This is all running in the GPU. That's why they call it Rapids. And now I'm going to take, and I'll re-upload this with the -1 and that error removed. This time lets me time it. We're using XGBoost. It's a multi-class classification, so we're using softmax, which is standard for that sort of thing. We're using GPU, history, and 1 GPU. And we'll get a warning that I want to talk about in a moment, something I'm probably going to do in a future video. Let's go ahead and run this. You can see it's training, and notice that log loss is decreasing. This is, if you've worked with XGBoost, this is a very familiar sort of look. It is giving me a warning on NGBUs that that's been deprecated. Single process multi-GPU training is no longer supported. That's actually kind of smart that they did it, but it makes it a little more painful. What that means is if you're using more than 1 GPU, if I was using 2, that's not supported. You've got to use something called Dask or Spark to make that happen. Because basically they had a lot of code in there to parallelize this and split it up amongst GPUs, and they were able to simplify the code by not reinventing the wheel and using Dask. Let me know, would you be interested in seeing this work with Dask? Do you want me to use multi-GPUs on XGBoost and show you how that happens? It'd be kind of an interesting video. Let me know in the comments. And it trains through and it's done. And that's it. We could now do anything else we wanted to do with this classifier that we created. This ran entirely on the GPU. not using CPU memory. So normally you would send things to the GPU, process it, bring it back. That's the whole point of Rapids, is just keeping this straight through pipeline. And this is all based on Pandas. Thank you for watching this video, and if you're interested in seeing maybe more on AWS, let me know in the comments, give me a like. If there's other cloud platforms that you're interested, let me know in the comments. That's the only way I really know. That lets me see what to make future videos about. Would you like to see more on Blazing SQL? This builds right upon this technology, and it's a natural extension of this. Thank you for watching this video, and please subscribe to my YouTube channel.